Hello everyone. Welcome to today's class. In the field of precision measurement in manufacturing, coordinate measuring machines, CMMs, play a vital role. They efficiently capture point data from part surfaces, providing accurate references for quality control and product design. However, to fully leverage the capabilities of a CMM, proper probe configuration and calibration are essential. This lesson will cover two main topics. Through this lesson, I hope everyone can describe and operate the joystick control of a coordinate measuring machine, CMM, including controlling machine movement, setting motion speed, and handling emergencies. Master the configuration and calibration process of probes, including selecting probes, setting angles, measuring with a reference sphere, and analyzing results to ensure measurement accuracy. Next, let's look at the probe configuration and calibration. The joystick control of a CMM is the manual operation device. The operator can manually control the movement of the machine, handle emergencies, set axis movement speeds, and reset the system as needed. Next, we will take the hexagon joystick control as an example to explain how to use the control box. As shown in the diagram, the joystick allows the operator to manually drive the CMM to move along the X, Y, and Z axis. The speed knob controls the movement speed of the CMM. The power on button supplies power to the joystick, while the emergency stop button enables the emergency stop of the equipment. When the probe activation light is on, it indicates that the probe is in the activated state, and this light should remain on during the measurement process. When the slow speed knob light is on, the CMM enters a slow movement state. The delete point button is used to manually remove a mistakenly measured point. The move point button is used to manually add movement points in automatic programming. When the axis lock light is on, it indicates that the machine can move along that axis. The lock/unlock button is used to mount or remove the probe suction cup. The up button is used to adjust the probe's angle. The operation mode is manual, and during measurement, you can switch between three modes: match, pat, and pro. The execute/pause light indicates whether the CMM is in the execution state. The probe system of a CMM is a sensor system for data acquisition. During part measurement, the probe system is used to detect the workpiece and collect the point data from the part surface. Therefore, before using the probe system, both the hardware and software configurations must be set according to the measurement requirements. The image shows two different configurations of probe systems,
which mainly consist of the probe head, probe,
stylus, and related accessories.
The probe head is the component
that connects the CMM's moving axis to the probe. The probe signal is transmitted
through the probe head and connected
to the CMM's control system via the probe interface. The probe is a key component of the CMM, responsible for collecting measurement data. It acts as the triggering switch that detects the measured part, and its main body consists of the sensing sensor. The stylus and accessories include the stylus, extension rods, adapters, and other components. Styluses come in different shapes and sizes, such as ball-shaped, heart-shaped, and disc-shaped. The typical structure of a ball-shaped stylus consists of a measuring rod with a ruby tip. Probe calibration, also known as probe qualification, is a critical step in the measurement process. Errors generated during calibration can impact the final measurement results, especially when calibrating probes at different positions, angles, and lengths. The accuracy of calibration is particularly important, as any precision issues discovered later may require recalibration, increasing workload and reducing efficiency. The basic principle of stylus calibration is to use a recognized reference standard to determine the true diameter and positional relationship of the probe. Typically, the reference standard being adopted is a high-precision standard ball, with a diameter of 10 to 50 millimeters and roundness of less than 0.1 microns. The errors of basic values and shape of these balls have been calibrated according to metrological standards. To ensure measurement accuracy, the standard ball must be calibrated regularly. During probe calibration, 4 or more measurement points, usually 8 to 12 points, are evenly taken on the surface of the standard ball using point contact. The software then fits a virtual sphere based on the coordinates of these points and the center point of the Ruby sphere, calculating the center coordinates and diameter of the virtual sphere. The difference between the diameter of the virtual sphere and the standard ball gives the equivalent diameter of the calibrated probe. Probe calibration generally involves 5 steps: configuring the probe, adding angles, defining the standard ball, calibrating the stylus, and reviewing the results. Next, we will learn how to perform the probe calibration operation through practical steps. Open the measurement software and click New Program. Name the program as Student ID 1. Choose the unit as millimeters, and click OK to enter the program editing interface. Start with probe configuration. You can name the probe as 001-1.
First, configure the probe head.
The model is HHMIMAB with 2 rotation angles. The adapter is HPTB1. The sensor is HPTMESF. And the probe is 2 by 40 millimeters. Add angles, A90B 180. A45B 90. And click OK. Select all 3 probe tips. Click Measure. Set the number of measurement points to 12, the retract distance to 2.54 millimeters, the movement distance to 50 millimeters, and the contact speed to 2. Choose the standard ball. The identifier for the tool can be the diameter of the standard ball. Here, the diameter of the standard ball is 15.053 millimeters, and the support vector is 0, 0, 1. With a diameter of 15.053 millimeters. Click OK. Choose the mode: manual, automatic, or full automatic. Here, select DCC plus DCC for the full automatic mode. Set the number of layers to 3, the angle to 70 degrees, and the angle to 90 degrees for the perpendicular. Select all probe tips, click Measure, OK. 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 And OK. Then start the measurement process. Adjust the probe angle to A45B 90. And press the Confirm button. Then adjust the probe angle to A90B 180. And press the Confirm button. These are the steps for probe calibration. In this lesson, we focused on learning how to use the 3-coordinate measurement machine's control box, configure the probe system, and perform probe calibration. Through the practical demonstration, we gained a deeper understanding of the importance of these steps and their specific operational methods. I hope everyone can apply this knowledge to improve measurement precision and efficiency in future work. Finally, please reflect on today's lesson and complete the following exercises to consolidate the knowledge you've learned and deepen your understanding. This concludes our lesson. See you next time.